Good evening, students. So the today's is electrochemistry part 2. In electrochemistry part 1, so we discuss the construction and working of what electrochemical cell and also electrode potential, EMF of a cell and also cell representation of what a Daniell cell. Now the second part is the electrochemical cell and Gibbs energy of reaction. So here electrical work done, the electrical work done, so is equals to what? The electrical work done is equals to charge passed multiply by what? Multiply by electrical potential. Multiply by what? Electrical potential. So this is what the electrical work done. Electrical work done is equals to charge passed multiplied by what? Electrical potential. Suppose if you get more or maximum work done by galvanic cell. So what you have to do? You have to pass a charge reversibly. So this is the maximum work done by what? Galvanic cell. So maximum work done, for example, the work done by galvanic cell when charge is passed reversibly is equal to what? Is equal to decrease in what? Decrease in free energy. Decrease in what? Free energy. So what is the expression? So now here the delta Z change in free energy is equals to minus, this is the decrease, N into F. N into F is nothing but a total charge pass multiplied by what? Multiplied by what? Electrical potential. For example, for a reaction. So zinc solid plus copper plus 2 aqueous. So it gives zinc plus 2 aqueous and copper solid. So this is the overall cell reaction of what? Daniell cell. And you have to apply this reaction for what? The relation between electrochemical cell and the Gibbs energy of a reaction. So we can write delta Z is equals to, what is the N? N is nothing but a oxidation number or change in oxidation number. So now it is a 2F, this is what? 2E, F what? E cell. So this is called what? This is the relation between what? The electrochemical cell and the Gibbs energy of what? Reaction. So EF cell is an intensive property. This is a intensive property. So this is a intensive property. Already you know that what is the intensive property? The property which not depends. So next delta G is nothing but a extensive. This is nothing but a extensive property. So for example, so now I can take here. Suppose if the reactions carried all the concentration or unity, if the concentration of the reactant, if all the concentration of what reactants are unity, or the concentration of reactants are unity, so here E of cell is equals to E naught of cell. E naught of cell. So now I can write here. So what is the expression? What is the final expression? So this is nothing but a delta C is equals to minus of what F. So if all the concentration of reactants are unity, so E of cell is equals to E naught of cell. So now I can write here, this is what E naught of cell. This is the expression or the relation between electrochemical cell and the Gibbs energy of what? Reaction. Now problems or some in-text questions or exercise is based on what? EMF of a cell and equilibrium constant and the relation between electrochemical cell and the Gibbs energy of the reaction. The first problem or first exercise, represent the cell in which the following reaction takes place. Magnesium solid plus 2 Ag plus the concentration is 0.001 m and it gives rise to Mg plus 2 0.130 m and plus 2 Ag solid. Calculate its E of cell if E naught of cell is equal to 3.17. The question is represent this cell. Represent this cell. Already you know that how to represent this cell. So while represent this cell, the metal should be at the extreme end. First is the cell representation solution. The cell representation. What is the cell representation? The first I can write the cell represent, which is the Mg is what? Oxidation half cell and Ag plus is a reduction half cell. So oxidation half cell is always left hand side and the reduction half cell is always on right hand side. So the metal should be at the extreme end. These two metals are separated about the salt bridge. First Mg, yes, this is the Mg, the magnesium, and this magnesium is dipped in what? Dipped in what? Mg plus 2. So this is, and these two electrodes are separated by what? Salt bridge. This is indicates what? Salt bridge. Mg plus 2 is a oxidation half cell, and this line it indicates what? Salt bridge. Next, which is the reduction half cell? Ag plus. So you know that. So this is what? Ag plus and this is what? Ag. So the metal is always at extreme end. This is one more question. Give the cell representation of the following reaction. Okay, this is okay. The second is the calculates its E of cell. Calculate its E of cell. So how can you calculate E of cell? Okay, the cell representation is over. Now is the second case. First case is cell representation. Second is calculate E of cell. What is the expression? E of cell is equals to E naught of what? Cell minus of 0.0591 divided by N log of oxidation half cell divided by reduction half cell, which is the oxidation Mg plus 2. This is the Mg plus 2. This is the oxidation half cell. What is the reduction half cell? Ag plus 2 Ag. Now I can write this is the Ag plus, this is what? Square. This is what? Square. Now I can write what is the E of cell? E of cell. What is the E naught of cell? E naught of cell is nothing but a 3.179 minus 0.0591. What is the N? N is what? Oxidation number or loss or gain of electron. How many electrons are loss or gained? Mg to Mg plus 2. This is what? N is equals to 2. Now log of, this is the log. What is the Mg plus 2 concentration? Mg plus 2 concentration is 0.130. And what is the concentration of what? Ag plus? 0.001 m concentration. This is what? Square. Yes, now E of cell is equals to, now I can write this is what? 3.17 and 0.0591 divided by 2 is nothing but a 0.02955. Now I can take this is the log 0.130. This is, now it is minus 1, minus 2, minus 3, minus 4. This is nothing but a 10 to the power of what? Minus 4 square. Okay, yes, now how to continue here. Now E of cell is equals to 3.17. E of cell is equals to 3.17. Yes, now 0.02955 log of S, log of what? 0.130, and this 10 to the power of minus 4 square is nothing but a 10 to the power of what? 10 to the power of what? Minus 8. Yes. Now this is 3.17, 0.02955 log of 0.130 minus 8 comes to numerator, so it is what? 10 to the power of what? 8. Now it is 3.17, 0.02955. Now this point moves here. Now it is becomes log of what? 1.30. One point moves here towards right. So this is 1.30, and it is a 10 to the power of minus 1. One point moves, so it is 1 point is moved, so it is 10 raised to minus 1, 10 raised to minus 1, and 10 raised to plus 8 is equals to 10 to the power of what? 7. Now it is 3.17, 0.02955, and you have to apply log. You have to apply log. Log A into B. Log A into B is nothing but a log. 1 point log A into B, log A plus log B. Log of what? 10 to the power of what? 7. Log of 10 to the power of 7. Now it is 3.17, 0.02955, and now it is what? Anybody? Yes, sir. Log of 1.30. Before log of 1.30, what is the characteristic? The characteristic log of 1.30 characteristic is 0. So log 1.30 is nothing but a, you see the log 13 column. So what is the value is 1139. Log a to the power of x, x log a is nothing but a 7 log 10. It is a 7 log 10. You know that log 10 equal to 1. So it is 3.17 and 0.02955, and you know that it is into, and log 10 is equals to 1, and it is how much? It is 0.1139. Now I can write here 3.17 minus you have to multiply 0.02955 into 7.1139, so we can get 0.210, and you have to subtract, so we can get E of cell of what? The magnesium electrode is dipped in Mg+2, and the silver electrode is dipped in what? Silver solution of concentration of 0.130 and 0.001 m. So we can get E of cell is equals to 2.96 volt. So this is the representation of the cell is the first case. In the second case is a calculated E of cell at a different concentration. So please take down this. Okay, second problem. Calculate the EMF of the cell in which the following reaction takes place. The nickel solid plus 2 Ag plus concentration is 0.02 m. Ni+2 concentration is 0.160 m plus 2 Ag solid. The standard E0 of a cell is given 1.05. In the previous problem, the question is you have to give the cell representation. Here no cell representation, direct you have to calculate what? E of cell. So now I can go for solution. Solution. The first, what is the expression? What is the expression? S. What is the expression? I can write here. E of cell is equals to S. E0 of what? Cell minus of 0.0591 divided by N. Log of oxidation half cell divided by reduction of, which is the oxidation. Here which is the oxidation? Nickel to nickel plus 2 is a oxidation. This is Ni+2. Divided by which is the reduction? Ag plus. This is what? Ag plus. This is a square. Okay, S. Now I can go for S. Now I can go for this here. Yes, I can calculate E of cell is equals to S. E of cell is equals to, what is the E0 of cell? E0 of cell is, what is the E0 of cell? E0 of cell is given 1.05. Yes, 1.05 minus of 0.0591. What is the N? Loss or gain of electron. How many electrons are loss or gain? 2. So N is equals to 2. Yes, log of. What is the concentration of nickel? Concentration of nickel is 0.160. And what is the concentration of Az plus? 0.002. This is what square. Yes, now you know that. Yes, 1.05. What is the 0.049 divided by 2? Already know that 0.02955. Log of 0.160. And now I have to move this point towards right. It is minus 1, minus 2, minus 3. It means 10 to the power of what? Minus 3. This is what? Square. 2 into 10 to the power of minus 3 square. Yes, now I can write here. Okay, one more step I will write here. So 1.05, 0.02955. Yes, log of what? 0.160. 2 square is what? 4. And it is into 10 to the power of what? 10 to the power of what? Minus 6. 10 to the power of minus 6. Yes. Now here I can write here 1.05, 0.02955. Now I can write here log of 0.160 divided by 4. 10 raised to minus 6 comes to the numerator. It is a 10 to the power of 6. Now 1.05, 0.02955. So log of 0.160 divided by what? 4. So we can get what, anybody? So we can get 0.04. 0.04 into 10 to the power of what? 6. Yes. 1.05, 0.02955. And this point moves here. Minus 1, minus 2, minus 2. Plus 6. It is what? 4 into 10 to the power of what? 4. Yes, 10 to the power of 4. Yes. Sorry. Log, yes. Log of, sorry, it is what here? Log of 0.04 into 10 to the power of what? 6. So, now here, I can write here, minus 1, minus 2, so it is nothing but a log of what? 4 into 10 to the power of what? 4. Minus 1, minus 2 plus 6, 10 to the power of 4, it is log 4. Yes. Now, 1.05, 0.02955. So, now log A into B. Log A into B is what? Log 4 plus of what? Log of what? 10 to the power of 4. Yes, here 1.05, 0.02955. So you know that. What is the characteristic? Log 4, only one digit. So log 0. Log 4 is what? 0 is the characteristic. Log 4 means log 40. Log 40 is nothing but a 6021. You see the log 40. So first column is 6021. So plus of log A to the power of x. X log A. This is what anybody? It is nothing but a log of what anybody? Log of 4 log 10. Yes. Now 1.05, 0.0, okay, 0.02955. Yes, now log 10 is equals to, this is 10. Yes, it is what? Log 10. Log 10 is equals to 1. Only is what in it? Log 4 plus 0.6021. 4.6021. Yes, now it is 1.05 and you have to multiply 0.02955 into 4.6021. 4.6021. So we can get here, we can get 0.135. 0.135. So how to subtract? You have to subtract. So here final answer E of cell is equal to 1.05 minus 0.135. So we can get what? 0.91 volt. So this is the E of cell when the nickel electrode is dipped in nickel plus 2 solution, silver electrode is dipped in silver plus solution at a concentration of what 0.160 and 0.002 m. The third problem. This problem is purely based on the relation between EMF of a cell and Gibbs energy change. What is the expression? Now the solution. What is the expression? The delta Z naught is equals to, what is the expression? Delta Z naught is equals to, what is the delta Z naught? Standard free energy change, and N into F, this is what everybody? E naught of cell. This is the expression. This third problem is purely based on the relation between the standard free energy change and EMF of a cell. Yes. The standard electrode potential for a Daniell cell is 1.1 volt. What is the given? E naught of cells. E naught of cell of what? Daniell cell is always 1.1 volt. Okay. Calculate the standard Gibbs energy for the reaction. In this reaction, the electron loss or gain, 2 electrons are loss or gain. So N is equals to 2. N is equals to 2, and you have to find out. Delta Z naught. They are very important for examination or CET or NEET, even though theory examination 2 marks question. Now this is the delta Z naught is equals to, what is N? How many electrons are loss or gain? 2. N equal to 2. What is the Faraday? Faraday is always 96,500. And what is the E naught of cell? E naught of cell of Daniell cell is 1.1 volt. So now delta Z naught is equals to minus of, we have to multiply 2 into 96,500 into 1.1 volt. So we can get 212,300. What is the unit? It is a joule per mole. It is also correct. But if you want answer in what? Kilojoule. There's now the delta Z naught is equal to, and you move the points towards what? Me on the left. 10 raised to 1, 10 raised to 2, 10 raised to 3. 212. This is what? 212. Point what? 3. So 10 raised to 3 is nothing but a kilo. This is what? A kilojoule per. This is what? Kilojoule per mole. This is the calculation of what? The free energy when E naught of cell is given. Yes. Now the fourth problem. The first two problems is based on electrochemical cell, and third problem is based on what? The relation between free energy change and electrochemical cell. Now the fourth problem is the problem is based on the relation between equilibrium constant and what? EMF of a cell. What is the expression? E naught of what cell is equals to? E naught of cell is equals to 0.0591 divided by N log of what? Kc. This is the relationship between EMF of a cell and equilibrium constant. Yes. Now, so here now the E naught of cell is given. What is the E naught of cell? The E naught of cell is what? 0.46. What is given? The given E naught of cell is equals to 0.46 volt. Okay. So what is the N? How many electrons are loss or gain? Electrons loss or gain are 2. So it is what? N equal to 2. So how to find out Kc? Kc is called what? Equilibrium constant. Yes. What is the E naught of cell? E naught of cell is equals to 0.46 is equals to 0.059 divided by what? N equal to 2. Yes. Now log of. So now it is a log of what? Log of what? Kc. Log of what? Kc. Now I can write here. So what is this log of Kc? Log of Kc is equals to 2 into 0.46 divided by 0.0591. Now it is the log of what? Kc. How to multiply 2 into 0.496 is nothing but it is how much? 0.92. It is how much? 0.92 divided by 0.0591. Now log of what? Kc, and you have to divide 0.92 divided by 0.0591. So we can get what? We can get what? 15.56. Now Kc is equals to, NT log of what? NT log of what? 15.56. Now Kc, you take what? The log table. In this log table you have to see the NT log of what? 0.56. NT log of what? 0.56. So we can get what? 3921. And this is okay. So always you have to put a point after one digit. This is 3.92. So it is 10 raised to, sorry, it is 15 means what? 15 is nothing but a 10 to the power of what? 15. So this is the Kc is equals to 3.91 into 10 to the power of 15. Next, the problem number 5. The cell in which the following reaction occurs: 2Fe plus 3 plus 2I minus, it gives rise to 2Fe plus 2 aqueous plus I2, has E naught of cell equal to 0.236 volt at 298 Kelvin. Calculate the standard Gibbs energy and equilibrium constant. Here two cases are there. The first you have to find out standard Gibbs energy, and the second you have to find out equilibrium constant. Yes, now I can write this. Case 1. In case 1, what you have to find out? Standard Gibbs energy. Delta Z naught is equals to minus of NF. This is what? E naught of cell. Yes, what is this E naught of cell? What is E naught of cell is given? What is the E naught of cell? E naught of cell is equal to 0.236 volt. Yes, you know that. What is the Faraday? Faraday is equals to 96,500 coulomb. What is the N? N is loss or gain of electron. How many electron? Fe plus 3. Fe plus 3 to Fe plus 2. How many electron loss? 1. But here 2 Fe plus 3 means 2 electrons lost. So N is equals to 2. Yes, you have to substitute. Yes, delta Z naught is equals to minus 2 is N is equals to 2, and Faraday is equals to 96,500. What is the E naught of cell? What is the E naught of cell? E naught of cell is equal to 0.236 volt. Now I can write the delta Z naught is equals to, how to multiply 2 into 96,500 and 0.236 volt. So we can get 45548 joule per mole. 45548 joule per mole. Suppose if you want the answer in what? Kilojoule, just have to move this point. 10 raised to 1, 10 raised to 2, 10 raised to 3. 45.5. 10 raised to 3 is nothing but a kilo. This is what? Kilojoule per mole. So this is the case 1. But what is the case 2? What is the case 2? Case 2 here. In case 1, standard Gibbs energy is what? In case 2, I have to find out equilibrium constant. What is the expression for equilibrium constant? You know that E naught of cell is equals to 0.0591 divided by what? N. And now it is what? Log of what? Kc. Log of what? Kc. Yes. So what is the E naught of cell? Already you know that. What is the E naught of cell is given? 0.236. 0.0591. What is the N? N is equals to 2. And this is what? Log of what? Kc. Log of what? Kc. Yes. Now I can write here. The log of Kc is equals to 2 into 0.236 divided by 0.0591. 05. Next, log of what? Log of what? Kc is equals to, yes, you have to multiply 2 into 0.236. So we can get 0.471. 0.472 divided by 0.0591. Now I can write here log of what? Log of what? Kc divide 0.472 divided by 0.0591. So we can get 7.98. Now how to find out equilibrium constant? Kc is equals to NT log of what? NT log of what? 7.98. Now Kc is equals to, you see the NT log in a log table, 0.980 column. 0.980 column is what? 9 550. Always after one digit you have to put point, and 7 is nothing but it is a 10 to the power of 7. This is the calculation of what? Equilibrium constant. Standard hydrogen electrode. This standard hydrogen electrode is also called half cell. And the standard hydrogen electrode is also called what? Reference electrode. The standard hydrogen electrode is also called reference electrode. Why it is called reference electrode? Because the electrode potential of hydrogen, standard electrode potential of hydrogen is 0 at all temperature. So that's why it is called what? Reference electrode. So with help of this standard hydrogen electrode, so we can measure or determine the electrode potential of, or standard electrode potential of what? Other electrode. So that's it is called reference electrode. So how do you represent this standard hydrogen electrode? The platinum solid, it absorbs what? H2 gas. It absorbs what? H2 gas, and it is dipped in a solution of what? Hydrogen ion concentration of 1 molar. So this is the cell representation of what? Standard hydrogen electrode. And the next the reaction takes place. For example, this is H plus, and it takes what? Electron, where the equilibrium is set up, and it forms what? 1/2 H2 gas. What is the standard hydrogen electrode? The hydrogen electrode develops a potential equal to 0 at a pressure of what? 1 bar, and the concentration of solution is 1 molar. So it is called what? Standard hydrogen electrode. In the examination, explain the construction and working of what? Standard hydrogen electrode. The standard hydrogen electrode is consist of a rectangular. The standard hydrogen electrode is consist of a rectangular platinum foil. This is the rectangular platinum foil. This rectangular platinum foil is coated with what? Platinum black, and it is connected to what? It is sealed to what? The glass tube, and it is enclosed in what? It is enclosed in a bell-shaped jar. When hydrogen gas passes through it at a pressure of what? 1 bar. So, and this hydrogen electrode is dipped in what? The hydrogen ion concentration of what? 1 molar. So here it develops what? Potential. So here, this hydrogen electrode is dipped in what? 1 molar H plus, where both oxidized and reduced form of this hydrogen electrode is maintained as what? Maintained as what? Unity. It is maintained as what? Unity. So what it implies? What it implies? It implies what it implies. So the hydrogen gas having a pressure of what? 1 bar, and the solution of hydrogen in concentration is 1 molar. So in the examination, explain the construction and working of hydrogen electrode. Simply, the standard hydrogen electrode is consist of a rectangular platinum foil, and is coated with what? Platinum foil, and is dipped in what? 1 molar H plus ion concentration. When hydrogen gases passes through at a pressure of what? 1 bar, where both oxidized and reduced form of what? Hydrogen is maintained as a unity, and it implies the hydrogen gas having a pressure of 1 bar, and the concentration of solution is 1 molar. Now this is the very important is the how to represent what? A standard hydrogen electrode. This is the platinum solid. It absorbs what? H2 gas at a pressure of what? 1 bar, and at a temperature of 298 Kelvin, and it absorbs what? H2 gas, and it is dipped in what? It's dipped in what? 1 molar H plus ion concentration. Now, standard hydrogen electrode is a reference electrode. The electrode potential of standard hydrogen electrode is always 0 at a temperature of 298 Kelvin at okay 298 Kelvin. So now the measurement of electrode potential, it is very important. If you want to determine the electrode potential of other electrodes like copper and the zinc, you have to combine with what? You have to combine with what? Standard hydrogen electrode. So now to determine standard electrode potential, determine the standard electrode potential, to determine the standard electrode potential of what? Copper. So how can you determine? To determine the standard electrode potential of copper, how can you determine? So if you want to determine the standard electrode potential of copper, you have to combine with what? You have to combine with what? Standard hydrogen electrode. You have to combine with the standard hydrogen electrode. You have to combine with the standard hydrogen electrode, because the standard electrode potential of hydrogen is what? Hydrogen is 0, and it is also called reference electrode. So now what is the cell representation? Now the cell representation, yes, cell representation. So in the cell representation of what? To determine the standard electrode potential of copper. Yes, now I can write, this is the platinum, this is the solid, it absorbs what? H2 gas, it absorbs what? H2 gas, and is dipped in what? It dipped in what? 1 molar aqueous solution, 1 molar aqueous solution. And now these two electrodes are separated what? Salt bridge. Now this is what? Copper plus 2, and now the copper is dipped in what? Copper plus 2. Okay. So now, so this is also 1 molar concentration. Okay. This is also 1 molar. So how can you find out? You know that what is the E of cell? What is the E naught of? What is the E of cell? So E of cell is equals to, or E naught of cell is equals to. So E naught of what? RHE, right hand side electrode, minus E naught of what? LHE. LHE means what? Left hand side electrode. Okay, right hand side electrode minus left hand side. So E naught of cell is equals to, so E naught of cell is equals to S. So what is the RHE? Right hand side electrode. This is the right hand side electrode. So this is the E naught of what? Copper. So now which is the left hand side electrode? Left hand side electrode is what? Hydrogen. Yes, this is what? Hydrogen. Yes. The electrode potential of hydrogen is what? 0. Now the E naught of cell is equals to, so E naught of what? Copper, and it is what? E naught of hydrogen is equal to 0. So it is nothing but E naught of what? Cell is equals to E naught of what? Copper. So what you have to do? In one container you have to take what? Standard hydrogen. Sorry, first you have to take standard hydrogen electrode, and you have to couple, or it is combined with what? The copper electrode. So next you have to connect these two electrodes to what? Emitter. So we can get what? E naught of cell. So whatever the E naught of cell, so we can get, that is equals to what? It is equals to what? E naught of copper. So this is the determination or the measurement of standard electrode potential of what? Copper. Similarly to determine the electrode potential, standard electrode potential of zinc. So to determine, similarly to determine electrode potential of what? Zinc. So how can it? And if you want to determine the standard electrode potential of zinc, again you have to combine with what? You have to combine with what? Combine with what? Standard hydrogen electrode. Combine with standard hydrogen electrode, because it is a reference electrode. Why we are selecting this? Because it is a electrode potential of hydrogen is 0, and it is called what? Reference electrode. So to determine the electrode potential of zinc, so what you have to do? What is the cell representation? Cell representation. Yes, cell representation. Where to determine what? Electrode potential of zinc. Now I can write here, the zinc electrode is dipped in what? Zinc solution, and it is separated by what? Salt bridge. Next is what? This is the H plus. Next it is what? H2 gas. So which is absorbed from what? Solid platinum. So this is the cell representation of what? To determine the electrode or standard electrode potential of what? Zinc. So Now I can write here what is the E of cell or what is the E naught of cell. E naught of cell is equals to ERHE, right hand side electrode, minus of what? Left hand side electrode. Yes, E naught of cell is equals to E naught of cell. What is the right hand side electrode? Which is the right hand side electrode here? Hydrogen. Yes, the right hand side electrode is what? Hydrogen. Which is the left hand side electrode? The left hand side electrode is zinc. So we know that. So electrode potential of hydrogen is 0. Now I can write here E naught of a cell is equals to, and E naught of hydrogen is 0. This is what everybody, E naught of what? Zinc. So when zinc electrode and the copper electrode is connected to what? The emitter, so we can get what? E naught of cell. That E naught of cell, is nothing but a E naught of the value of what? E naught of what? The value of what? E naught of zinc. So we know that. So the E naught of what? The E naught of zinc is always minus 0.76 volt. Minus because so E naught of cell is equal to minus of E naught of zinc. E naught of zinc is equal to minus of what? E naught of cell. So this is the standard electrode potential of what? Zinc. Okay. This problem is purely based on standard hydrogen electrode. Calculate the potential of hydrogen electrode in contact with a solution of whose pH is equals to 10. Yes. What is the expression for this solution? E of what? Hydrogen means potential of hydrogen electrode is equals to the standard electrode potential of hydrogen minus 0.0591 divided by N. So only here only one electrode. So one electrode means you have to take log of what? 1 divided by H plus ion concentration. If two electrodes are there, log of oxidation divided by reduction. But here only one, so I have to take log 1 divided by H plus. You know that. What is the already we know that E naught of or standard electrode potential of hydrogen is 0. So what is the valency of hydrogen? N is equals to 1. So already you know that if pH is equals to 10, if hydrogen ion concentration is equals to 10, what is the H plus ion concentration? H plus ion concentration is equals to 10 to the power of what? Minus 10. So this type of problem already we have studied in what? The PUC first year, the topic chemical equilibrium. If pH is 10, so H plus ion concentration is 10 to the power of minus 10. If H plus ion concentration is 10 to the power of minus 10, so pH is equals to 10. So now here E of what? Electrode potential of hydrogen is equals to, so this is for 1 mole concentration, what is the E naught of hydrogen? 0. So for 10 to the power of minus 10 m concentration, what is the E of hydrogen? Now we are calculating. Yes. So E naught of hydrogen is 0. Yes. 0.059 divided by 1 log of what? 1 divided by 10 to the power of what? 10 to the power of what? Minus 10. Yes. Now here I can write, yes, E of hydrogen, E of what? Hydrogen minus of 0.0591 log of 1 divided by 10 to the power of minus 10. When it is comes to the numerator, it is log of 10 to the power of 10. Yes, here I can write E of hydrogen is equals to, yes, minus of 0.0591 log 10 to the log 8 to the power of x, x log s. Similarly, log 10 to the power of 10, 10 log 10. It is nothing but 10 log 10. So minus 0.0591 into 10 log 10 is equals to 1. So now E of what? Hydrogen is equals to 0.591 volts. So this is the E of what? Hydrogen at a concentration of 10 to the power of minus 10 m. So E of hydrogen at 1 mole concentration is equal to E naught of hydrogen is equal to 0. Answer is minus of 0.591. So this is the E of hydrogen at 10 to the power of minus 10 m. If E of hydrogen at 1 mole concentration is 0.